Welcome to Why Math Works. Today I will present an interesting two envelopes paradox in Roblox game. Imagine a Roblox-style reward challenge. You enter a neon game room and see two mystery reward envelopes, envelope A and envelope B. The game gives you one rule. One envelope contains exactly twice as many dollars as the other. You do not know which one is larger. You only know that one is double the other. Let us say the player chooses envelope A. The envelope opens, dollars burst out, and inside we see $100. Now the game asks a new question. Do you keep this envelope, or switch to the other one? At first, switching looks like the smarter move. If envelope A contains $100, then envelope B could contain either $50 or $200. 50 if the 100 we saw is the larger amount. 200 if the 100 is the smaller amount. If those two outcomes look equally likely, then the expected value of switching is 125, so the game seems to reward switching. And this is why the paradox is so convincing. The arithmetic looks fine. The average looks larger. Nothing in the calculation feels suspicious. It looks exactly like the kind of strategy a smart Roblox player should use. But now comes the paradox. Suppose you had started with envelope B instead. Then you could repeat exactly the same logic again. You would once again conclude that switching is better. So envelope A seems worse than envelope B, and envelope B seems worse than envelope A. That is impossible. Let us run through it to resolve this problem. So where is the mistake? The arithmetic is not the problem. The real problem is hidden inside the probabilities. We quietly assume that after seeing $100, the two possibilities, 50 or 200, are equally likely. But that assumption is not automatically true. Once you open an envelope and observe an amount, that amount changes what is believable. Suppose this Roblox game has a maximum possible reward of $200. If you open your envelope and find $200, then the other envelope cannot contain $400. That option is impossible, so switching would clearly not be equally attractive anymore. In real games, there is usually some range, limit, or prior belief about what rewards are possible. That means the chance that the other box is larger or smaller depends on the amount you actually observe. Low values may make switching look more plausible. High values may make switching look less plausible. So the observed amount changes the odds. There is also the issue of risk. Imagine opening a legendary Roblox reward envelope and seeing $1 million. Even if some expected value argument tempted you to switch, would you really want to risk dropping to 500,000 just for the chance to go up to 2 million? Many players would not. Expected value is useful, but it is not the whole story. So the two envelopes paradox does not show that math is broken. It shows how easy it is to misuse expected value when the hidden probability assumptions are not properly defined. The contradiction appears only because we smuggled in an unjustified 50-50 assumption. Once the probabilities are modeled correctly, the paradox disappears. That is all for this time. Please write in the comments what video you'd like next. Maybe a new video about mathematical paradoxes, or one about non-traditional ways to solve math problems. Thanks for watching. If you enjoyed this video, please give it a like, subscribe, leave a comment and share it. Thank you, and stay tuned for another interesting video coming soon.